Our goal here is to create this kind of growing effect. So we have prepared the collision geometry, and this is the growing geometry. So let's see how we implement it. The key idea is to affect the volume by a velocity field, and we can custom map the velocity field. So first we turn it into a VDB polygon, and then we are just going to advect this SDF volume by a velocity field. So let's jump into the solver. Basically, we are going to first compute the gradient. The gradient of the SDF is basically just normal to the surface. And we smooth the gradient. And then what we're going to do is advect the volume by this gradient field. So we can see the advection. Yeah. But if we just advect by a gradient, the result is going to be very boring. We can see that if we are just, wait a second. If we just advect by the gradient, basically it's just a silly expanding volume, so it's going to be very boring. So the key idea is to mix with other attributes, like the curvature of the surface, or an external. We can also use an external noise, the curl noise, to pump inside the solver, and we combine them together using the volume block. And so basically we are trying to create a kind of a custom volume affecting field, a velocity field, and use it to affect our volume. So let's see it grow again, this time using some curvature and the curl noise. So we can have this kind of like the coral growth effect, and then we use VDB smooth and convert it back to the polygon. So the result will be like this. Another thing to mention about is the collision geometry. We also wire in the collision geometry here. We also use a volume. So when we are trying to build our custom velocity volume used to affect the original volume, we're going to set the velocity to be 0 if we are overlapping with this volume. So in the volume block, we also sample the collider, and if the collider has something, and then we're just going to set the result to be 0. So we won't collide with the collision geometry.